Oh, hey, what's happening there, YouTube? It's Brian House here for Housework, and today we are going to be taking my concept, the idea for the Platen bracket for the Revolution 2x72 belt grinder build, and hopefully making it come into life in pure, hard, cold American steel. That's right, we are embarking on a whole new journey right here in the workshop and studio. If you haven't been following along with the Revolution 2x72 belt grinder build, I'll create a link right up here so you can follow along with that. It's been a great project in the making of conceptualizing and designing and then ultimately building and manufacturing a 2x72 belt grinder that I feel has a lot of potential for people who want a 2x72 but can't afford, say, a very expensive commercial version of it. And this one allows you to build it yourself for a fraction of the price, but it gives you all of those same features of a manufactured belt grinder, which I think we've actually achieved that concept. And so many people, hundreds of people have built it, and it's really cool to see it popping up all over the world. But just recently, I have acquired a Crossfire Pro made by Langmuir Systems. I'm not affiliated with them. I just like what they're up to and purchased this in November of 2019. And a few days ago it arrived. My son Dexter and I assembled it, put it all together, fine-tuned it, got it all working, and now I feel as if we can actually create something with this thing, something that actually holds true to the CAD drawings. We've been working in Fusion 360 and drawing up a Platen bracket for the Revolution 2x72. Up until now, most people have been using a piece of angle iron. I used a piece of tube steel, cut it down, and made it work, and it worked fine. But this is a much more elegant solution, I believe, and a whole lot more fun to put together. So over the last couple of days, I've been talking about that here on the channel, and one of my favorite commenters, his name is Millar, and he lives out in California. He has been walking me through and guiding me through some of the processes of taking CAD drawings and then converting them over to tool paths. We've been sort of going back and forth in design, and it just so happens that he has a Crossfire, like the original version of the Crossfire, in his workshop over in California. So he's able to prototype and conceptualize the same stuff. Him and I have come up with a pretty good combination of the two concepts. His idea, a little bit thicker, a little bit more steel, a little bit more weld surface area, and my idea was kind of the basis for all of that. It kind of came together, both of our minds working together, and with technology, it doesn't matter that we're 3,000 miles apart, that we're able to work on these ideas and put them all together. This is my first original version of the what we're calling the foot, the Platen bracket foot, and this is just a little bit too weak. It's a little too small, so we've bulked it up and did a couple of other minor changes. It also comes with 2 legs, 2 feet, and a Platen bracket backer that actually holds the hardened piece of steel up against whatever you're working on. So there's all these little pieces and components, and I think we've sorted it out. So today, we are going to pump that data that we drew in Fusion 360 into the Crossfire Pro, let it spit out the print onto steel, and then we're going to assemble it and see if it actually functions. Why this is exciting to me is because just a few days ago, if I wanted to design something like this and build something like this, the process of actually cutting it out of steel and manufacturing it would be extremely difficult and long and time-consuming and dangerous and dirty work. But instead, I pump that data into this machine. It cuts it out into cold hard American steel, and with a few welds, we have a functional piece that can be used on the Revolution 2x72. So anyhow, without further ado, let's get started. I'm gonna go ahead and get the metal cutting, and then we're gonna see how good it turns out, and then hopefully put it all together and see if it'll actually work. Okay, so here's the basic cutouts for all of the pieces. This is the Platen backer here, and these are the feet that go up against the D plate and the legs that hold up this side. Essentially what you see here is what's going to be cut out on the table on 1/4 inch steel, and it It isn't that complicated, although you do have to set up quite a few settings just to make sure, you know, where the tool path goes, how fast it moves across these paths, like inches per minute is important, how much amperage you use, how much air pressure you use, and then also where the pierce points are. So it generates code based on these different things, and you can come in here and you can tell it, you know, what geometry you want it to cut out, and then in what direction and from which direction. All those settings matter, believe it or not, and if you don't follow that, your pieces will not be true to size. As you can see here, we've got the plate steel on the table. This is a 24-inch by 24-inch piece of 1/4-inch steel. We have been running some tests to try to get the cutting correct, so you can see some of the attempts there in the steel. And what's kind of interesting about this is you can pick and choose wherever 0 axis is, so that you can just keep making test cuts like this and run them over and over and over if you want. And if you understand X, Y, and Z axes, you can make this, you know, you can pretty much cut anything you want with very little waste. This is the air drying system. It's made by HTP. This is a recommendation from somebody I know on Instagram. He purchased one. It's got a stage 3 desiccant, which I guess is a bunch of blue beads go inside of this thing and effectively remove all of the moisture from the air. This is a really important piece to have when to ensure that red hose there goes into the plasma cutter. This is a 45-watt razor weld, and you really need to make sure that your air is dry, which is the reason why we put this in line. So something to take into consideration while you're doing this is these little green arcs that are coming in. Those are your entry points into the cut for the machine, or for the machine to read, so it knows where to start the cut around any particular piece. Wherever you decide to do that, if you don't give it enough clearance, you'll get a dimple or like an imperfection in the steel. So I put them in places where I don't care so much, like for instance, this part of the leg right here. I don't really care that there's going to be a dimple there, because there's going to be a weld there anyway, and it'll cover it up. And you can see I did the same thing over here. It does not bother me. Now, what I don't know is if the holes are going to cut okay or not. I sure hope they do. It is what it is. I'm still learning about that, and Malara sent me some data on it, but I'm not 100% on it yet. So I'm going to give it a shot and get some experience today to see. You can also run a simulation on this to kind of see where the head of the laser cutter is going to go, and it will actually run a cool simulation. The play button, and it'll show you where the cuts are going to happen. That way, less chance of it actually failing on you. It's kind of a cool feature of Fusion 360. Looks complicated, but it actually isn't too bad. So now that we know that our tool paths are right, we're gonna send this to post-process, which is just clicking here in Fusion. And I've already preset all of these settings. This is like your pierce delay and pierce height. All of those settings are pumped into a file that you get from Langmuir Systems, and it will know exactly what to enter all this data into the G code. So this is fire control. This is the piece of software that comes with the cutter when you get it. You open up your file. You can see here, there's all of our tool paths. You can see the orange line is where it's going to cut, the blue line is the travel line, and then in our case 0 is right down here. So we need to move the torch to give it enough clearance to cut the piece right here. Now we've got the torch positioned where we want it. This is at 0, and all is set and ready to cut. Now all we have to do is cross our fingers and hope for the best and hit go. All right, so the holes don't look half bad. Those are somewhat acceptable, I guess. Not too bad. I'd like to refine it. This one looks a little bit better. And the cut pieces, I can break them free. They look pretty darn good too. Break some of that dross off the back. A lot of times that just snaps off with a hammer. Not too bad. I'll dig these other ones out from underneath. Very nice. Yeah, it's falling right off. Yeah. Might have to tap a couple of these with a hammer here just to clean them up, but no big deal. All right, so you can see how the design works. It's pretty straightforward and simple. These two pieces nest together, and the way that I designed it is so that you can pop a weld right in this space right here, and then also another weld right across the front here, and that will give you a nice flat surface on the bottom. You could even go ahead and pop some welds down here and then grind them away after the fact, just to give it some more rigidity. So I use a big magnet to do this. Just set my piece on it and let it kind of position itself. This one is really strong. Throw it down in there. Get it all set. I like to use a square to make sure that it's aligned properly. Pretty good in that direction. This one's a little more difficult. Doesn't have to be perfect. This has to be close. All right, so let's pop a weld. Give it a quick pop. Now that we've got our quick pop on the top there, I'm going to go ahead and pop a weld on the front. Okay, so here they both are after I've cleaned them up on the grinder. You can see there's opportunity to splash a little bit of a weld down underneath as well. I didn't do it quite so much on this side. These two pieces had quite a bit of oil or something on them, so I couldn't get a decent weld. I got a lot of spatter and different things happening there, but this one, I learned my lesson on this one. and cleaned this one quite a bit with acetone before I welded it up. You can see it much cleaner weld, much nicer weld here, and really no reason to clean this up. I think in the future, I don't know, I kind of like the geometry here. I don't think I would play with that too much. It leaves a nice spot for a weld. I was thinking if I made a little bit more of a radius there, it'd be easier to clean up, but then you'd have less space to weld right there. But my first time doing this, really, so you know, I think I'll learn as I go. But yeah, clean steel equates to a clean weld, and this is a classic version of that. This one's not too bad. I managed to clean it up a little bit and pop some more welds in there, but it took a lot more grinding on this side. So I'm not concerned about the structural integrity of it. It'll be fine. It's just ugly. But yeah, so let's move on to actually fabricating the whole piece on the Platen, on the D plate. All right, so this is my prototyped Platen D plate that I used to build the Revolution. It's a pretty good size. It's like 14.6 inches all the way out to the outside here. And it's a big boy, but this is a perfect opportunity to upgrade this thing and get it going. The hardware that comes with the hardware kit is a 1/4 and they come with washers and lock washers and regular washers, and I like to use both. So in this case, I'm going to go ahead and mount these just loosely so I can get kind of an idea of where this plate is going to go. Okay, so one of the things I was looking for when I was setting this up was how level it is with the wheel. So now that I've got it fairly close, I feel like I can pop a weld on this side and it should straighten right up. And then we'll finish our welds on the back side. But first we clean the steel. All right, now you can see they're sitting very level to the Platen wheel. That's important as your piece is worked, that this isn't cockeyed. Yeah, it looks like a little bit of work to get it right, but I'll tell you, taking a little time to do this really does help. It makes your decent grinder a great grinder when all these pieces are in alignment to each other. Okay, so now we got it tacked in place. I'm gonna pop a few select welds on the inside of this. I don't want to get this real hot because 1/4 inch steel will warp when it's real hot. So I'm just gonna take it nice and slow and just pop, you know, maybe 3, 1, 2, 3, 1, 2, 3, and then we'll pull it out of the Platen as a whole and do the outside. All right, well, there you have it. As you saw at the end of the video, I did put a piece of 80 CRV2. This is 2 inches wide by 11 inches long. So you can see how absolutely rock solid that is. And it's 0.187 inches thick. Now, this piece of steel came from a company in New Jersey called New Jersey Steel Baron. I buy this to actually make knives, but the cool thing about it is if it's annealed, which is soft, I can drill into it and tap into it like you saw, and then create this platen face. Now, this will go in the kiln, and I will heat treat it and temper it so that it actually stays nice and hard. The reason why I like doing it like this is because this is a factory cut piece of steel, so it's exactly 2 inches wide, and it will fit over, my belt will fit right over it, and it's got a nice sharp edge on both sides. There's no variance in this edge, it's perfect. That's kind of the reason why I do it, and it's high carbon steel, so it actually can be hardened. I am excited about this. I just think this is fantastic. If you got something out of today's video, make sure you hit that thumbs up button, and if you're not already subscribed, hit that subscribe button. And if you hit that little bell, you'll get a notification every time I upload something to YouTube. As always, there's many ways to support my channel, and by far the best way is to go to housemade.us and purchase the plans for the Revolution, buy the parts, the plate steel, the nuts, bolts, and all that. If you've already done that, I truly appreciate you. Thank you so much for supporting my work, and I hope you're enjoying the build of the Revolution as I did. Also, very soon I will be putting together another video where I will be using the laser cut steel and the hardware pack, and I'll show you how easy it is to actually build the Revolution once you have all those pieces in hand. I hope to see you guys on the next video. I really truly do appreciate you all. Thank you for watching. My name is Brian House, and this has been Housework.